we're asked to convert the point -3, 4, -1 to spherical coordinates. So the given point has Cartesian coordinates or rectangular coordinates, and therefore x equals -3, y equals 4, and z equals -1. To find the spherical coordinates, we'll need to find rho, theta, phi using our formulas here below. Where rho is the distance between the point and the origin, this distance here, theta is the angle counterclockwise from the pole or positive x-axis in the xy plane, this angle here. And finally, phi is the angle between the positive z-axis and the point, which is this angle here. Let's begin by determining rho, where rho squared is equal to x squared plus y squared plus z squared. So we'd have rho squared equals -3 squared plus 4 squared plus -1 squared. So we have rho squared is equal to 9 plus 16 plus 1. So rho squared is equal to 26. And now we take the square root of both sides of the equation. So algebraically, we'd have two solutions where rho equals plus or minus the square root of 26. But since rho is a distance, we only use the positive value of square root 26. So the first coordinate is positive square root 26. And now we'll find our angle theta. And we need to be careful when finding theta to make sure we find the angle theta that terminates in the correct quadrant. To make sure we do this, we'll plot the point at -3, 4 in the xy plane. So from the origin, we'd move left 3 units, and then up 4 units, which would be here, and therefore angle theta must terminate along this side in the second quadrant. So there's an infinite number of angles that terminate along this side in the second quadrant, but we're asked to find positive values, so we'll find the least positive value for angle theta, which would be this angle here. And we know that tangent theta is equal to y divided by x, so tangent theta is equal to 4 divided by -3, or -4/3. So if tangent theta is equal to -4/3, then theta is equal to arctangent or inverse tangent of -4/3. And now we'll go to the calculator. Let's make sure we are in radian mode, so we'll press the mode key. Notice radian is highlighted, so we'll go back to the home screen, and we'll enter second tangent for inverse tangent, -4 divided by 3, close parenthesis, and enter. Notice how the calculator is giving us a negative angle that terminates in the fourth quadrant. So this is not the angle we're looking for, but this angle still does have a tangent function value of -4/3. The reason the calculator is giving us this angle is because, remember, the output or range of inverse tangent is from -π/2 to +π/2 radians. So for our next step, let's go ahead and sketch this angle, which terminates in the fourth quadrant. And notice how this angle would be approximately -0.9273 radians. So the calculator gave us this angle here in the fourth quadrant, which was approximately -0.9273 radians. Well, the angle in the second quadrant that has the same tangent function value would have to have the same reference angle. So this reference angle here would be approximately 0.9273 radians, which means the angle theta we're looking for would be pi radians minus 0.9273 radians, where it would be approximately equal to this difference. So let's go back to the calculator. And because we have this negative angle already here, we can just press plus pi, press enter. So the angle theta we're looking for is approximately 2.2143 radians. To one decimal place, this would be approximately 2.2 radians. So when determining theta, it is important to sketch the point x, y in the xy plane to make sure we determine the correct theta. And then finally for phi, we know cosine phi is equal to z, which is -1, divided by the square root of x squared plus y squared plus c squared, which is just rho, which we already know is the square root of 26. So if cosine phi is equal to -1 divided by square root of 26, then phi is equal to arc cosine or inverse cosine of -1 divided by square root of 26. So now we'll go back to the calculator one more time, and we'll enter second cosine, -1 divided by square root 26, right arrow, close parenthesis, and enter. So phi is approximately 1.7682 radians, which to one decimal place would be approximately 1.8 radians. So here are spherical coordinates for the point given in Cartesian coordinates. I hope you found this helpful.